Hey guys, I welcome you all to the day 2 of SQL series. In today's session, we'll be learning about SQL Data Warehousing. Now let's see the agenda of the day. Firstly, we will begin with Introduction to Data Mart. Post that, we will introduce you to data modeling. Then later on, we'll be learning about different types of data modeling like conceptual, logical, and physical data modeling. So, this is the agenda of the day.
So before moving on with the session, please subscribe to our channel.
And also hit the bell icon for the upcoming updates from our channel. And also, if you enjoy our content, you can leave a like.
Data Mart is nothing but a subset of our data warehouse. So consider this is my the transactional database which we are having, okay, in real time. So this is operational systems. So we are not going to load in a single stage to the data warehouse. We do have so many stages will be available. Okay, so from the OLTP to OLAP transfer, right? Data transfer. So definitely we do have multiple stages available in the real time. So like staging area is one of the stages in the ETL process. Like we will land all the data from different OL system to OLTP system to staging. From the staging to we will move the data to data warehouse. So from the data warehouse, a subset of data warehouse we will create either logically or separate data mart will be created. Again, the data mart also a database only, but it is a logically divided. So how we do have 1 TB of hard disk have been divided like C drive, D drive, and E drive the same way. So here also we will logically divide the data warehouse or one particular database into multiple data mart. The data mart will have a subject oriented informations based on their business. So consider this is this is the difference between data warehouse and data mart. The data warehouse, it will have all the enterprise data. Okay, so it will have all the enterprise data, but data mart will have a particular subject, a department by data. So here we do have multiple subject areas are available in this particular data warehouse, but here it will be a single subject area. Each data mart will have single subject area. So multiple data sources, definitely it will have multiple. From the multiple data sources, we will accumulate all the data. We will integrate the data into warehouse, but here it will be limited data source. So might be the source for data mart. Again, we need to do the ETL process to fetch the data from data warehouse to data mart. Here we used to do one ETL process. Again, here ETL tool will be introduced. So here it will occupy large memory. Okay, the data warehouse will occupy large memory, but the data mart will occupy limited memory. So this will take lot of time to implement this data warehouse, but the data mart will take some shorter time to implement it. So this is the major difference between data mart and data warehouse. So we do have different types of data mart in the real time. So for example, three different types of data marts are available. So the first types of data mart is independent data mart. Okay, so the dependent data mart and independent data mart and hybrid data mart. So what is meant by independent data mart? So here we do have OLTP systems. So from the OLTP we are moving the data to data warehouse. So from the warehouse we are fetching the data for our data mart. So this is called dependent data mart. The data mart is dependent on the data warehouse. Okay, so from the warehouse we are pulling the data. So the data is first extracted from the OLTP system and then populated to the data mart, the central data warehouse to data mart. So from the warehouse the data travels to the data mart. But here independent data mart, here the data warehouse will not be available. Okay, so directly the data mart will be loaded from OLTP source. So this is called independent data mart. And then we do have hybrid data mart. the hybrid data mart, the data mart will get the data from either from the OLTP system or from the data warehouse system. So this is the three different data mart available in the data warehouse. So what is the data modeling? So data modeling is nothing but, so for example, if the business users, so will give us the business related terms, okay, business related terminologies. He knows or she knows the business and she wants to convert the business into a model, okay, data model. So how to convert that? So we do have a different methodology to draw this, okay, to create that data model. So we do have three different method. So one is called conceptual model and logical model and physical data model. So what it does mean? So what is conceptual model? So how to create this conceptual model, and what is logical model? What is physical model? We will see one by one. You assume that, so we are going to create the data model for one of the particular uh, uh, particular online portal or something. Okay, so online uh, portal, the online product selling portal we are going to create it. This online portal, right? Definitely they do have they need to have. So these are all the tables we should have. So in order to have our customers informations, we need to have the customer table. In order to maintain our employees details, we will have the employees tables. In order to maintain the customers accounts, we will have the accounts table. In order to maintain the product information, we'll have the product, we have the region table. So to have the different regions on the sales, to analyze which region is performing well, to analyze which product is performing well, so which account they have transferring the money or doing the transaction the money, which employee is doing well. Okay, so how is the performance on the customers? Okay, so like this, we do have a lot of tables are involved in the data modeling. So if you consider these tables, so countries table, regions table, accounts table, merchant table, so a lot of tables are available. Okay, so in this customer table, so each customer will be identified by customer ID. So this ID we will call it as a primary key in a database. Okay, so then we will have all other information of our customer. So for example, customer name. So customer name might be duplicated. Okay, so two customers may have same name, but the customer ID will be different. The customer mobile number. Okay, we can get the customer mobile number to give them the update. The mobile number, we can get the date of birth of the customer to identify, to analyze the age of the customers. So which type of customers, which age group of the customers is ordering the product, okay, more. So in order to get that, we need to have the date of birth. So we will get the address of the customers, which location the customer is ordering more, and the city of the customer and country of the customer from working at different countries. So these are all called the different dimensions. Okay, different dimensions of the customers. So if you consider customer is one of the table, then this is the customer ID is the primary key. So primary key in the sense it will not allow duplicate to the columns. So primary key and customer name, the mobile number, the date of birth is the different dimensions of the customers. This is the dimension table we do have. An employee table the same way, employee ID, employee name, mobile number, employee skill set, employee years of experience, and employee city, address, all those we can get it. The account number will be the primary key, and what is the type of account, what is the active account or inactive account. So different details we can get the accounts. So these are all the tables are dimension tables. Okay, so different dimensions of the data, and by using these dimensions, if I'm going to create a sales, okay, sales, this table is called it as fact table. The sense fact table will have the the each key values here. Which customer has ordered the product? Okay, which employee is helped to purchase the product? Employee ID. Okay, then which product he has purchased? Product ID. Then which account number. Okay, which account number he has purchased, which region he has purchased the product. So at the end of the day, I want to analyze the summarized data on the regions, which region is performing well. Okay, which merchant is performing well. I will have the merchant ID. This is the way I will get all the key values from the table. Okay, key values from the table. So these key values are called as foreign keys. Okay, the integrity, to maintain the integrity, we'll have the foreign keys. So normalization, we will see more on the primary key and foreign key, but as of now, we understand this foreign key primary key relationship. So each column is called as foreign key. That is the reference is coming from the base table, the dimension table. So this is like the fact table. We have all the keys we have, and then we do have the quantity. How much quantity he has purchased the product. Okay, for example, 2 quantities he has purchased. What is the one quantity unit price? One quantity unit price, and what is the total quantity he has purchased or total price? So if two quantities is purchased, one quantity is $100, then the total price will be $200. Okay, so these three are call it as the measures, the measurable values. These three are call it as the measures. Why? Because these are the measurable values, and these column is called as the dimensions. So these are like the foreign keys will be maintained in the fact table. This is the fact table. F underscore sales is the fact table. The fact table is derived from the dimension table to have all the customers information, the employee. We will not keep all the customers information here. Just we will keep the customer ID, which customer he has purchased, which employee has purchased, help to purchase, which product has been purchased, and which account number, from which account he has purchased, which region ID, and which merchant ID, all those. In order to, after that, if I want to get this particular total sales for the day, so even I will use the date key. Okay, date ID or date key to have the date. So date dimensions, you will get the date. So which date? So after that, so I will combine, I will sum of this total price for a particular day, and then I will get the merchant on the ranking, and I will go for the merchant ID, join with this merchant table, and then get which merchant is having the highest sales today. So this is what the fact and dimension tables are related. So again, the data modeling is having the three different types. One is conceptual model, and logical model, and physical model.
Just a quick info, guys. Intellipaat provides online SQL training in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
So what is that conceptual model? So you have concept, okay, you have business concept. Okay, so I want to create a data model for this particular business. Okay, you take the online food delivering uh, the business. Okay, online food delivering business. So this is the one of the concept I have as of now. So for this, I want to draw a model, data model. So what are the tables needed for this food delivering uh, particular business? So I will have the time. Okay, I will have the date and time dimensions. I will have the product. Okay, different product I will have. I will have the different store to purchase the product, all those. So whatever the dimension tables you needed for all the for this particular business, you will draw all the dimension tables like time dimensions, product, store, and regions, and the merchant account, whatever the dimensions you want to have, you have to draw all the dimensions. So with that only name, okay, only name, no need to mention any detailed informations. Okay, so these are called as entities. Entities is nothing but tables. A technical word is table, but in the conceptual data model we will call it as entity. So what are the entities we are going to have? All the entities we are going to draw. Okay, so includes the important entities and the relationship among them. Okay, so what is the relationship we are going to create? So the tables are like divided into two parts. One is the part is having the primary keys. So whatever the keys you want to have, for example, this product table might have the product ID. The store table will have the store ID. The sales table will have all the foreign keys here. So this is what the conceptual diagram we will write. So here we will not write any attributes. Attributes is nothing but column names. Since it is a conceptual data model, we are not going to write any primary keys, foreign keys, all those. We are just mentioning the entity names and how the entities are related to each other. So this is called a conceptual model. So you can have a simple paper and pen to draw this, or you can have this paint. Okay, so just you can drag and drop all those, and then you can have this conceptual data model. In this conceptual data model, it will be highly abstract. Okay, so it will be highly abstract. So you cannot have any column names. You cannot have any column names. It will be easily understood. Okay, it will be easily understood each and every model. So this conceptual data model will have this highly abstract. Okay, it will not have any attributes names. Attributes name in the sense the field name, the column names. It will be easily understand. You can easily enhance. So you can add more entities to the particular model. Okay, so only the entities are visible. So you should not write any. So it's like a first step of the data model. So we will have all the entities. So only entities we will drop that all the relationship between the tables entities. So no software tool is required to define a conceptual data model. Since it is only the concept, we will no need to have any software tool to draw this. So this is one of the conceptual data model. So time, product, sales, store, regions, account, merchant. So n number of tables can be connected with the fact tables. The fact tables might be connected with different dimension tables as well. So this is called a conceptual data model. Then we have the logical data model. In this logical meta model, it has been enhanced from the conceptual data model. So the first step is we will draw this all the conceptual data model. After that, in this conceptual data model, we will have this what is the primary key we will use. Okay, so definitely each entity we need to have the primary key. For this time dimensions, we will have the date primary key, date key. Then product, it will have obviously it's a product ID. So it is like a description of the column, not the column name, not the exact column name we will write. So simply we will write product ID, okay, with space also. If it is a column name, so definitely if it is an attribute name, definitely we should write with underscore. So since it is a description, so you can write with this. Okay, so date descriptions, month descriptions, and year, week, all those. So whatever the attributes you want to have, you can have all the attributes here. In the product table, in the product entity, you can have product ID, product description, category, and category descriptions, unit price, created time, and updated time. You can have all those. And then the sales, the store, right? The store ID, store descriptions, which region is from the store, the region name, created date, updated date, all those you can have it. And then in the store, as I told, the upper part of the fact table will have all the foreign keys. So from the store table you will have the store ID, from the product table you will have the product ID, from the time table you will have the date key. After that, item sold, item amount. I told, right, it will be the measures, only the measures, the foreign keys and measures will be there on the fact table. So item sold is the quantity. Again, the sales amount is the price. So these two are called as measures. Okay, foreign keys and measures will be maintained on the fact table. So this is what we will maintain in the logical data model. We will not write exact column names. We will not write any primary keys and all those. We will simply mention that the column description. It includes all the entities and relationship among them, all the attributes in the sense the column names, all the attributes for each entity are specified. The primary keys for each entity is specified. The foreign keys also identified and specified with this fact table, and normalization occurs at this level. Normalization in the sense, okay, so for example, I do have store table. I'm assuming that in the store table I have the region and region name. Okay, so I can split this store table into one more table. Okay, consider this is called normalization. Anyhow, we are going to see tomorrow. So consider this is one more table as the region table we are creating. So the region table we are creating here. Okay, and this region table. So we are going to delete these two fields from this table, and here we have only have the region ID. Okay, region ID column. So this region ID is connected with this region ID in this table. So this is region ID we have, region ID. So and then region name. So a single dimension table is again splitted into other dimension table to avoid the data redundancy. So how we will avoid the data redundancy? So because if I have a particular store, okay, a particular store in a different regions, okay, so I do have different regions, and in a single region I have multiple store. 100 stores are there in a single regions. So the 100 regions informations will have 100 times the region names will be repeated. To avoid this, we will have only the region ID here, and we will take that region name only one time here, region ID and region, so that the data redundancy will be avoided by using the normalization. So this is called normalization. So normalization occurs this level. So if any possibility of the normalization on the tables, we will split up this table into multiple tables. This is called logical data model. So presence of attributes. So definitely you will have the attributes present in each entity, and the key attributes, the primary key and foreign key, and the non-key attributes, the description you will have, right? The non-key attributes you will have. These are all the non-key attributes. This date is the key attributes. Here the product ID is the key attributes. Then primary key, foreign key relationship. Definitely will have the primary key and foreign key relationship. And user-friendly attribute names. You can have only the descriptions. No need to have the primary key and foreign key. Sorry, no need to have that entire column name. You can have these descriptions, and it will be more detailed than the conceptual model. So you'll have all the column names, right? So Erwin is the data modeling tool, or Power Designer, okay, can be used to create logical data models. So this data model we are going to create, and then this can be automatically converted to a physical data model with the help of this tool. So if you create the logical data model, so only this model, then the Erwin tool will convert this model into a physical data model. Okay, so it will create the table names, all those it will create with the columns. So this is the physical data model. See here. So each and every table will have the column attributes as well as the data type of the attributes and the data length of the attributes. Okay, for example, if you consider this is one of the table, the time table. Okay, so here the table name is mentioned as dim underscore time. So dim is nothing but dimensions. So dim underscore time, dim underscore product, fact underscore sales. As I told, the sales table will be a fact table. So this is the actual format we will give. Okay, so dim underscore store is a dimension table. The dimension tables are connected with the fact table here. So see here we have the all the column names underscore with underscore. Exact column name should be there. Okay, so what is the data type? For example, it is an integer or it is a varchar. So how much is the data length? That is also will be provided here. So detailed the logical model. From the logical model, the physical model will be automatically drawn by using any of the data modeling tool. So we can have the Erwin tool. So if you give this for the Erwin tool, if you give this model, so automatically it will convert that into this model. Okay, this model of data. So fact underscore sales. So definitely it will have the fact tables. So all the foreign keys. Again, it is also integer, then integer and float. So mostly it will have the ID columns, the key columns, and these are dimensions. So see here, the specification of all tables and columns will be maintained in this physical data model. The foreign keys are used to identify the relationship between the tables, and denormalization may be occur. Okay, denormalization is in the sense we will again we have splitted the tables, right? Two tables here might be merge these two tables into a single table. So if necessary, we will do this denormalization based on the requirement. So physical consideration may cause the physical data model, okay, to be quite different from the logical data model. So the physical data model again, it will create, okay, it will differ from each database. If it is Teradata, might be the varchar, it will be okay. The integer, big integer, okay. But if it is at Oracle, the integer might be number, the varchar might be varchar2. Okay, so different databases. So whenever we are having the Turbine date tool, if you create the logical data model, we should select what is the database we are going to apply this. So if you select Oracle, then based on this particular database, it will convert that logical into a physical data model. So this is the physical data model it will create. Then so entities referred as a tables here. So again, we will call it as, since it is a physical table. So here we are going to make the terminologies as table here. Okay, we will not call this as entity. We will call it as table. Attributes will be referred as column here. So database compatible tables, database again compatible the table names, database compatible column names we need to provide, and database specific data types also mentioned. So difficult for user to understand. So those who do not have any technical knowledge, so they were somewhat difficult to understand. But if they are seeing that, they can able to understand what is this column names. So overall, they can able to understand. But in detail level, they could not able to understand. Again, we can create the index, constraint, triggers, all the DB objects with this physical data model. So the create table structure has been created automatically for this physical data model, okay, by using any other tool. And this is what the tool will create the automatically logical data model to physical data model of the different versions, different database servers. Okay, so this is the concept of three different data model.
Just a quick info, guys. Intellipaat provides online SQL training in partnership with Microsoft. The course link of which is given in the description below.
Okay guys, we've come to the end of this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below.
Thanks for watching.